Hello, I'm Arlene Blum, the Executive Director of the Green Science Policy Institute, and I'm here with distinguished speakers to talk about the science and the policy around the No PFAS and Cosmetics Act. If you have questions, please put them in the chat. We'll have a discussion at the end. So to start, we're honored to have Jordan Dickinson, who's the Legislative Director for Representative Dan Kildee, who leads the PFAS task force, say a few words and kick us off.
Yeah, thanks, Arlene. I'll let our speakers get to most of it, but just want to give everyone a reminder about the PFAS task force, something led by my boss, Congressman Kildee, and Congressman Brian Fitzpatrick of Pennsylvania. We started it in 2019 with only 14 members. Now we're up over 60 members. And the point of the task force is to bring people together in Congress to learn more about PFAS, to let people know about events like this, let people know about legislation that's going on, and coordinate on what we're doing on PFAS. So I am glad to be joined with some of my friends who've been working on PFAS for a very long time. And I'll kick it back to them just to talk about PFAS and cosmetics. So thanks, Arlene.
Sure. Well, thank you, Jordan, and thanks to you and the task force for all your leadership and good work. It makes a huge difference. Jordan's been doing this, working hard for a long time. Really appreciate it. Well, our first speaker probably needs no introduction. It's Rob Bilott. He is the hero of the legal thriller Dark Waters, and even better, if you haven't read it yet, is his unforgettable memoir, Exposure, Poisoned Water, Corporate Greed, and One Lawyer's 20-year Battle Against DuPont. So, Rob, welcome.
Thank you, Arlene, and thanks to everybody for joining us this afternoon. Yeah, this is an incredibly important opportunity to talk about this, what has become a worldwide contamination problem of PFAS chemicals that are now showing up in the blood of virtually every person across the planet, living things all over the planet, in animals, in wildlife, in our drinking water. And this is something that's been going on for decades. These are all completely man-made chemicals. This class of chemicals we're going to be talking about, PFAS, per and polyfluoroalkylated substances. Quite a mouthful. That's why we call them abbreviating PFAS, or you might also heard of them as forever chemicals. All of these didn't exist on the planet really before World War II. All man-made chemicals, all sharing this kind of common chemical bond of carbons attached to fluorine. And they have been used in a wide variety of different products over the years. These chemicals first started being manufactured and pumped out into our world right after World War II, and have been out there in use for decades and decades. And what you're going to hear, and some of our speakers are going to talk about, are these chemicals present enormous potential public health threats and risks to our environment, to people who are exposed. And we're sitting here in the year 2021, still trying to figure out exactly how all of this happened. How did these chemicals get out there? How did they get into our environment? How did so much of this happen for so long without really the rest of us knowing that this was happening? And unfortunately, what we've learned over the last several decades is that although the manufacturers of these chemicals, companies like 3M and later DuPont and others that have been making these chemicals, have been well aware of the unique chemical structure of these chemicals and their ability to get out and stay in our environment, to essentially never break down once they get out there, which is why they're called forever chemicals, and to get into us and other living things and stay there and build up over time and present all kinds of toxicity concerns, cancer concerns. The companies making them understood these threats and were looking into these issues as early as the 1960s, 1970s, and we're doing all kinds of studies. And unfortunately, we're seeing all kinds of threats to human health and the environment, yet kept making them, kept increasing the production of these chemicals, and kept putting more and more of them out there. And so that they ended up into more and more products. And unfortunately, the laws, as they started to come out in the 70s and 80s, were essentially relying upon the companies to disclose this information to agencies like the US EPA and for state and federal regulators. But unfortunately, that didn't happen. This information was covered up and withheld from the scientific community, from the regulatory communities, and from the public for decades. And it was only in the last 10, 20 years through litigation, when people were trying to find out why cows were dying in West Virginia, that we first started to find out about the fact that these chemicals were out there, that they were in our environment, that they were in our drinking water, and how much had been known for how long about the toxicity and concerns of these chemicals. And it was over the last 20 years that we were able to bring that information out to the scientific community, to regulators, to the rest of the world, so that people can start understanding the threat that these chemicals pose. So over the last couple of decades, that information has finally slowly made its way out. And most of the information we have was historically about 2 of these chemicals, ones that had 8 carbons, C8s, things like PFOA, PFOS. And after all of this information finally started to get revealed to the world about the toxicity and the threats from these C8s, those chemicals slowly got phased out in the United States over the last 10, 15 years. But unfortunately, they were replaced with other very closely related chemicals in this same chemical family, the same chemical family of PFAS. A couple of carbons were knocked off. Instead of C8s, you now had C6s or C4s. Those chemicals started getting pumped out into our environment, into products. Most of this, again, we didn't really learn about until these lawsuits and litigation forced this information out. And most of what we've focused on to date has been the fact that these chemicals have gotten into our drinking water. So a lot of what has happened up to now has really focused on making sure we are identifying where these chemicals are in our water and stopping those exposures, making sure people aren't drinking that. But over the last several years, what we've come to understand is this stuff just isn't just in our drinking water. It isn't getting into our blood just from our water. It's out there in enormous variety of different products and different materials. One of which we're going to talk about today is in cosmetics. So what we're trying to do is make sure that people understand how much information is out there now that document and demonstrate and confirm the serious health risks that these chemicals pose, and to make sure that information's out there to manufacturers that understand these chemicals might be in the products that we're making, and should we be switching away from these and switching to safer alternatives. So I'm glad to be able to be on this panel and speak today, and I know others are going to talk a little more detail about what we know about the health threat from these chemicals. What do we know as far as how are they used in cosmetics? And what can we do to try to make sure that information is available so that people can move away from these materials and start using less dangerous, less toxic materials. So I'm honored to be here today with Dr. Birnbaum, Mr. Andrews, Dr. Blum, all of the folks here on the call that are going to help fill us in on why we need to address PFAS now in cosmetics as well. So thank you.
Thank you, Rob, for your eloquent words and for your decades of often lonely, incredibly hard work on PFAS. And so good to see your work coming to some fruition now. Well, our next speaker also has been working on PFAS for decades. She's one of our country's leading toxicologists. Linda Birnbaum used to direct the National Institute of Environmental Health Sciences and the National Toxicology Program. And she is continuing to do research and make a big difference in reducing harm from PFAS and other chemicals. Thank you, Linda.
Well, thank you very much, Arlene. I'm really very pleased to be able to be here and give what I would say is kind of a very, very brief introduction to the whole issue of PFAS and the health effects that okay. So again, what I want to tell you today is PFAS chemicals in cosmetics. I'm going to focus on that. And really the question is, what do we need to know about? So the first question, and Rob briefly talked about exposure, but I think, again, it's an important, this is diverse group of chemical compounds. In fact, EPA has a list of over 9,200 of them, which are used in industry and consumer products worldwide. And it's been 70 years since they've been in production, and the production really ramped up in the 70s and the 80s and the 90s. Drinking water has been a focus for much of the concern because that's, I think, where the PFAS were first being reported by Rob and other people. And I think that's important, but realize that they are found in various products, not only, for example, makeup and other cosmetics, but carpeting and fabrics, food paper, pots and pans. I'm sure many of you either used to have or still have Teflon pans, clothing, for example, that you may have used Scotchgard on to provide water repellency and stain repellency, fast food packaging and other kinds of cardboard packaging for food. And a major source are the firefighting foams that have been developed to put out oil and grease fires and have been used at essentially every military airport in the country, every domestic airport in the country, and many of your fire stations down the road. And the exposure that we have, it's not just that we're getting it in through our mouths, so we're ingesting it. Some of it can come in through our skin, and some of it we are actually inhaling as well. So I think the important thing is to understand that we all have PFAS in our body. The Center for Disease Control Prevention has been conducting a report card every 2 years, a statistically based summary of the American population, and has shown that over 98% of us have measurable PFAS. And it's not just the United States. These compounds are detected everywhere. Essentially, the levels, the good news is, and Rob kind of alluded to this, but 3M announced they would no longer make PFOA and PFOS starting in 1998, and they actually stopped making it in 2002, but other countries have picked up, and I should let you know that it's still made, many of these compounds are made in China. So if you, for example, look at this graph, what you can see is, yes, levels of PFOA came down from, they were higher in the past, and PFOS have come down. I would suggest that we're now starting to see flattening of that curve, just like we saw for PCBs because of recycling in the environment. But some of the other PFAS, like the C10, the PFDA, or the C6 that's related to PFOS, they haven't changed at all. I think that's important to realize. And then this is, I think, something, again, which is really important to look at, that while they've declined in our blood, and I think here's kind of an example, again, here's the PFOS and PFOA, but instead of blood, this is in breast milk of our nursing women. So we're exposing our infants to it. And what you can see, PFOA is a much less steep curve than PFOS, but these other compounds that you can see at the graph on your right, these are some of the alternatives that have since been made since 3M stopped making PFOA and PFOS. And in fact, what you can see there is a very, very rapid increase in the levels of this since, for example, around 2000 up until a year ago in the breast milk. So let's say the legacy ones were having a little less exposure, but not the alternatives. So PFAS have a wide range of health effects, and this is just summarizing very briefly the data that we know for those well-studied PFOS and PFOA. I think cancer has been seen in the C8 studies, both testicular and kidney, and there's suggestions of some other kinds of cancer as well. Things like ulcerative colitis, which is an autoimmune condition, so an impact on the immune system, high cholesterol, hypertension during pregnancy, often called preeclampsia, disruption of our endocrine system, especially of our thyroid hormones. And now evidence is growing for impacts on our estrogen and our androgens, so our sex hormone systems as well, liver malfunctions, increased body weight, even to obesity. And then I mentioned immune suppression, but there's also suppression of the immune response. And there's interference that has been demonstrated both with both in children and adults related to vaccines. Babies whose moms are highly exposed or more highly exposed have lower birth weight and are often small for gestational age. We're seeing impacts on puberty and impacts on fertility and actually early menopause in women. We're seeing reductions in circulating testosterone. And as I mentioned before, some other cancers have been implicated, if not totally really proven yet. So this is just a little graphic that I think is easier to remember, that PFAS is a multi-system toxicant. In fact, it affects pretty much every biological system in which there have been careful studies done. And this includes data from not only human data, which is what I focused on in the last slide, but we see very similar things in our animal studies and in our mechanistic studies. So impacts on our hormones, impacts on our immune systems, on our liver, on our pancreas. There's, I mentioned obesity, and I should have mentioned diabetes, impacts on our kidney dysfunction, as well as cancer of the kidneys, impacts not only on the testicular cancer, but impacts on our both male and female reproductive organs. And data is beginning to accumulate that this may also be impacting the development of the brain and behavior in our children as well, of great concern. I want to just mention that there are some really important research questions that need to be investigated. First of all, there's lots of PFAS out there that we are not measuring. Even people who are doing state-of-the-art measurement, if they're measuring 16 of them, that's a lot. There are a few that are mentioning maybe 29 or even 41 or even 51, but out of 93,000 compounds, that's not a very high percent. There have been a number of studies now indicating that at least in human samples, we are only accounting for somewhere between 30 and 60% of the PFAS that are circulating in our bodies. Then another question is, well, we've got all these PFAS that are out there. We know that water is kind of the final sink where they go. How do we get them out of the water? We can do a pretty good job of removing PFOA and PFOS by filtration using granular activated charcoal, but that doesn't take out all the alternatives. Incineration has not been tried on a large scale at all. And if we put them in a landfill, these forever chemicals may stay there. Hopefully they stay in the landfill forever. I think a question we're going to have to begin to address is the issue of essentiality. Where do we really need these chemicals? Are there some places that we absolutely have to have them because there are no alternatives and it's an essential use? But where can we deal with safer alternatives? And then we have to be really careful when we start using alternatives. Are the substitutes any safer? So this, as I mentioned, some of the things that are called the short chain PFAS, their levels are increasing dramatically, and the limited data we have on them, the limited safety information does not demonstrate that these things are that much less toxic than the existing ones. So there's a whole move now to say that these 92 plus chemicals, classes, individual chemical structures, and there are more being made all the time. We need to begin to take a class approach for these, just as EPA has done in the past, for example, for dioxins. And in fact, there are really too many PFAS for us ever to do adequate toxicity testing of all of them, as well as testing them in mixtures, which is the reality. Nobody is exposed to just one of these. We live in a soup of PFAS. And in fact, the National Academies opined several years ago that an approach that uses subclasses or classes to assess the chemicals is scientifically appropriate. So with that, I say thank you, and I look forward to any questions. If you haven't seen John Oliver's YouTube video, I highly recommend it. Thank you.
Thank you, Linda. So if you stop sharing your screen, I will share mine. Great. Yeah, so last week tonight, about 10 days ago, John Oliver had a very entertaining program, and he called strongly for the regulation of all PFAS as a class, which is something we really agree with. So that was pretty scary, Linda, all those health effects and that they're all over. But the reality is that when manufacturers are informed about the problem with PFAS, they start moving away from them. And government can help level the playing field to make this happen faster. Even once legislation is in the works, the industries tend to wake up. So now we're going to talk about some research. I'm part of a group of scientists, including Notre Dame, Indiana University, Toronto University, our institute, ETH Zurich, and we're doing studies on PFAS in various products. And we had a paper a few months ago on PFAS in cosmetics, where it talks about how from cosmetics, PFAS end up in our body and the sorts of products that contain the most PFAS. And then the big worry about how these are the forever chemicals down on the lower right. When they're disposed of, they tend to end up back in our water, our food, and in us. So why are there PFAS in cosmetics? Well, they do increase durability, spreadability, skin absorption. They're said to improve skin appearance or texture. However, over half the products did not have PFAS, so they're not necessary. And there's some big concerns. They can be absorbed through the skin or eaten, for example, from lipstick. And then, as we said, the disposal, when they go down the drain or to landfill, they can end up in our drinking water and back with us. So on a research paper, we looked at 231 cosmetics for high fluorine, which usually indicates the presence of PFAS, and discovered 52% of them had some fluorine. Most were in wear-resistant or long-lasting products. Then we took 29 of those samples, many of which had fairly high levels, and we measured a small number of individual PFAS. As Linda said, you can only measure for some, we don't know how to measure for all 9,200, but we can measure for a handful. And indeed, all the samples we chose contained several PFAS at measurable levels, and only one disclosed PFAS on the label. So this lack of transparency of what is in cosmetics and in other products is a huge problem. So it's hard to know there's PFAS. There's a PFAS, a C6, that means there's a chain of 6 carbons surrounded by fluorine that the FDA found unsafe to use in food packaging, and it was found in 28 of the 29 samples we measured. So just to look again at the data, the highest level was in waterproof mascara, perhaps no surprise. 82% of waterproof mascaras had PFAS, so that might be better avoided, at least now. And other eye products, it was about 58%. The other high was liquid lipstick, 62%. And lipstick is a problem because we tend to eat our lipstick, and the average woman over her lifetime who uses lipstick might actually eat pound levels of lipstick. So having PFAS in lipstick is not a good thing. Foundations, 63%. So all in all, the cosmetics we tested, 52% had PFAS. Now, where does it come from? In some cases, it's accidental. If we look at this scale, the water might be contaminated with PFAS inadvertently. Some of the ingredients might. Some ingredients might contain PFAS and the manufacturer might not know it. Then some fluorinated chemicals have disguised names. It doesn't say they're fluorinated, but PFAS is part of them. PFAS can be coming from the cosmetics packaging, and then it can be added deliberately. Indeed, it is on the label. PTFE especially is on the label of a number of PFAS. So I just want to end by saying that we don't have to have PFAS in our products. Our institute has a website, PFAS Central, for those who learn to love PFAS as we do, because it's so bad and so interesting. And you can read that top bar. It has news, science, policy, events on PFAS at PFAS Central. But the most popular page is PFAS Free, and it lists retailers and manufacturers that don't use any PFAS. For example, Credo is more than 100 brands of green cosmetics, none of which use any PFAS. So I think I agree with what Linda said. We have to think about the whole class of PFAS. We're never going to be measuring for all of them. So we need our cosmetics to move away from the whole class. And we've heard that the cosmetics industry has been alerted to this problem. They're working on it. We're working with some manufacturers. I think the No PFAS and Cosmetics Act, just the fact that it is bipartisan in both the House and Senate is such a good thing. And it is waking up the retailers and the manufacturers that they want to be ahead of regulation, and a lot of them want to get PFAS out of their products. So you're doing good work already, but if the legislation can move forward, it will be even better. So to tell us, let me stop sharing my screen. My slide. Okay. I was just going to end by saying that leading brands are acting to ban PFAS. They're testing products. They're trying to figure out when there are unlabeled PFAS. They are banning intentional uses of PFAS, and it actually can reduce cost. PFAS is expensive. Interestingly, the more upscale, more expensive cosmetics line are more likely to have PFAS than the less expensive ones. But I think they're all working now to find out where they are, or not all, but many are working to find out where the PFAS are and how they can reduce their use. And of course, we are pleased that many of the brands are supporting regulations like the No PFAS in Cosmetics Act. Introduce our next speaker. David Andrews is a senior scientist with the Environmental Working Group. He's been working for more than a decade to educate consumers, move markets away from harmful chemicals towards safer ones, protect our health. And EWG has a long history. They were the first NGO to really start working on PFAS and have been doing it for a long time and making a lot of good progress. So David.
Thank you, Arlene, and thanks for joining us, everyone. So I'm just going to quickly talk about this issue of PFAS in cosmetics, which seems like one of the more ludicrous applications of this chemistry, especially based on what we know about the health implications of these chemicals in particular. And so as Arlene mentioned, I'm a senior scientist at Environmental Working Group. One of the things we're known for, and what I've partially what I've worked on for over a decade, is our Skin Deep database. It has over 70,000 cosmetic products. We have over 7,000 ingredients in there. And so what this does is give us a snapshot of the marketplace in terms of at least what's on product labels and the known hazards of those ingredients on product labels. And so this information, we also have it available in the web app. What we're really trying to do is communicate this information to consumers in terms of potential concerns that may be in products they're using, and ultimately shift the market towards safer ingredients. And so the question is, how is this relevant potentially to PFAS? As Arlene mentioned, in the recent study she participated in, PFAS were found in over half of cosmetics, but only a small percentage of them had the PFAS ingredients on the label. And I think that stands out in particular because it highlights at least what is an easy target to and a place where we'd expect even higher levels of exposure. And previous studies did find that when PFAS was on the label, you had higher levels of PFAS in those products. And we do know that consumers are exposed to hundreds of unique chemicals and products. And actually in our database, we identified over 300 products from 50 brands using 13 different PFAS compounds. PTFE, or polytetrafluoroethylene, Teflon, was the most common ingredient found in cosmetics. This is similar to what's put on a pan, but often in cosmetics, it's ground up into a fine powder and applied in the product. And so it's a little bit unclear. There's a number of different potential uses. As Arlene mentioned, it was most commonly found in the mascara products, the PFAS chemicals, but there's really a range of different functions that these PFAS compounds can play in cosmetics. And oftentimes we may not necessarily have that information. FDA has summarized a few different uses for these chemicals, but ultimately we think they're all a concern. And actually the cosmetic ingredient review, so this is the cosmetic industry organization that reviews the safety of ingredients, found that for the vast majority of PFAS compounds, they didn't even have sufficient data to characterize whether or not use was safe. So this is kind of the industry self-regulating, highlighting the fact that these ingredients are being put into products without information on their safety. And so based on what we know in the recent paper that was highlighted by both Dr. Birnbaum and Dr. Blum, is that there's sufficient scientific evidence to consider PFAS as a class. And in the absence of data, really the assumption that these new compounds are of particular concern, especially ones without any safety information. So with this widespread use in chemicals, it highlights, what's going on with the Food and Drug Administration and cosmetics regulation. Fun fact, it turns out on our website, if you misspell any address, so if you're trying to go to Skin Deep and you misspell it, you'll get a 404 error page that says, just like the government's action on personal care safety product laws, this page doesn't exist. So we're kind of highlighting the lack of federal regulation anytime you misspell an address on our website. But ultimately, we think that's really an apt summary of the federal regulation of cosmetic products. For PFAS and other compounds. The Food, Drug, and Cosmetic Act is over 345 pages. There's just over a page and a half dedicated to cosmetic safety in there. So this is an incredibly short piece of legislation. It was passed into law in 1938. That's back when the world was in black and white, not in color, and hasn't been updated since then. So really just kind of highlighting how our understanding of chemicals and how chemicals interact with our body, how PFAS are incredibly toxic, have changed significantly, if not transformatively, over the last 80, 90 years. And yet our regulation, our oversight of these chemicals and how they're used in products has not been updated. And so that really leads me into the No PFAS and Cosmetics Act, introduced in the House and the Senate, bipartisan support. And there are other pieces of legislation moving towards overhauling all of cosmetics regulation. Mentioned down at the bottom, I don't think we need to go into detail here, but I think the important pieces are really highlighting the No PFAS and Cosmetics Act as places that are in need of support and in a place where we think there can be a significant shift in the market and really getting out all of these, getting out these ingredients in products where they still may exist. And ultimately, I think more needs to be done to ensure the entire supply chain is cleaned up and these chemicals aren't contaminating products through their packaging, through the processing or manufacturing. But really the first step is getting out all of these products that are on ingredient labels. And so with that, I'll turn it back to you, Arlene.
Okay, well, thank you, Dave, for your good work and the leadership long time of EWG on the PFAS problem. Okay, well, for our final speaker, we have Amy Aronson Levine, who works with Congresswoman Debbie Dingell, who has introduced the No PFAS and Cosmetics Act in the House. Maybe you can give us a little update, Amy, on what's happening.
Oh, apologies. I'm with Congresswoman Jan Schakowsky. Actually, I wanted to discuss a bill actually that my boss introduced just this past week, as David alluded to, as part of the Safer Beauty bill package. It's called the Toxic Free Beauty Act. It's based off of a California and Maryland law that ban some of the worst chemicals in cosmetics. Specifically, the Toxic Free Beauty Act would ban 11 of the worst chemicals and then the entire class of PFAS chemicals. So that's just one other bill in addition to Ms. Dingell's bill that is working to eliminate PFAS in its entirety.
Oh, thank you. And I knew that, Amy. I'm so sorry. I was going, has she changed offices? I had just heard that Tim from Debbie's office, Debbie Dingell's office, was going to speak, and he has a sore throat today. So somebody said you were his substitute. So anyway, thank you. We've worked together, and I apologize for the wrong office. And that's great to hear about your new bill. What is there a Senate equivalent? Tell us a little bit about the chances.
Yeah. Unfortunately, we don't have a Senate companion right now, but we are looking for avenues to get this into final legislation of some sort. So, right now, just looking for co-sponsors and additional support. The package as a whole, has over 100 different, NGO, supporters. So, it is a popular idea, and we are ready, as folks have said here, for cosmetics, updates to the law, and that's about everything.
Great. Well, hopefully some of the people on this call can help, and we'd certainly like to if we can. That's great you're doing that. Okay, well, thank you. So as I said, Tim, who is Debbie Dingell's legislative assistant, woke up with a sore throat. And so I asked him if he could just send us a couple of sentences about where we are on the No PFAS and Cosmetics Act in the House. So I'm just going to read you what Tim wrote. So he said that Congresswoman Dingell is pushing for a hearing on the bipartisan No PFAS and Cosmetics Act in the Energy and Commerce Committee later this fall. And the exact timing will depend on the reconciliation package currently being negotiated by the House and Senate, as well as discussions around the broader cosmetics reform legislation that Amy just told us about. So he wrote that given the outstanding need, Dingell's office will continue to make this act a priority moving forward. So that is the end of our talks. Let me just see.